Broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everyone, and welcome to today's webinar, Running a Top-Down Design Process. My name is Rob Romanowski. I'm the Director of Operations with 3HTI. And joining me today is Emily Pinto, Application Engineer from PTC outside of Pittsburgh. And she is also a proud graduate of the University of Pittsburgh. So I say that because my son is obsessed with the University of Pittsburgh, and he's only 13 years old. So at least he's picking a school with in-state tuition. But anyway, glad everybody could join us on the call. So everybody is going to be on mute during this time. If you have any questions, feel free to type them into the dashboard, and we will answer them at the end. We should be about, 25 minutes for the presentation, maybe 20, and leaves about 5 minutes at the end for a Q&A session. So without further ado, I want to ask our audience a quick question, Emily, before I pass everything over to you. If I can figure out how to do that. Interesting. I had a poll for the audience. So what I'm going to do is I'm going to instead of like me fumbling around and trying to find what happened to the poll that I just had, all I had to do was touch a button on, it disappeared on me. I'm just going to pass the control over to you.
Wonderful.
Oh, wait, hang on a second before you take control. I see what happened. So before you accept, hang on. Here we go.
Okay, no problem.
Here we go. There's the poll. For some reason, it got hidden behind some things. So just out of curiosity, what challenges is your design or engineering group facing today? And the reason I'm asking this poll is just to kind of get in the mindset of, where you are right now within your processes and what you might be, have some challenges with, because I think that'll some of these solutions you'll see within the presentation and the demo. So I'm just trying to make things fresh in front of mind. So there's multiple answers that you can pick. So you don't have to just pick one. And this feedback helps lead the demo. So thank you guys for voting. Let me close this out. And Emily, you can take control now. So once again, if you have any questions, just type them into your dashboard, and we'll answer them at the end of the presentation.
Okay, can we see my screen?
I do. Creo Advanced Assembly Extension.
Perfect. So hi everyone, I'm Emily Pinto. I work for PTC in the Virtual Center of Excellence. This is a group that gives high-level overviews of all of our different technology, and I've had the opportunity to work with Creo, and today we're going to talk about how the Advanced Assembly Extension works within the design process and those capabilities. So before we get into the solution, let's talk about some of the challenges with in industry and the design process. It's kind of the reason that PTC created this tool the way that they did. And that's that concurrent design processes are very time consuming. It can be difficult to manage distributed design teams. If you have lots of people working in different areas, they need to share information, and someone really needs to manage that to make sure that everyone has the information that they need, and that they're using the correct information to work from, right? So enforcing best practices and geometry sharing, all of that fun stuff. The issue is that without this management, you really have lost productivity and efficiency due to poor communication, because you get errors and rework. So when you have everyone referencing different lines, different surfaces, building parts in ways that don't really work well or fit well together, and certainly can't be changed all at the same time by changing one line, or you have maybe one person waiting for someone else to be done with a part so that they can use that part or a surface as a reference. This is all very inefficient and results in very error-prone models that are so difficult to change down the line. We also see an ability to securely protect and share company IP. That's because there are limited tools to prevent unauthorized access or use of proprietary data and information. So maybe you work with suppliers or partners or someone who should really have input or need to have some information about the assembly that you're building, but who you really don't want to have all of your detail, CAD data, and IP. So that there's really limited tools right now to do that. There are also limited tools for top-down design process, which means it can be very difficult to define assembly structure and enforce top-down design methodologies, as well as manage the assembly performance, because there really aren't dedicated tools to do this in the traditional CAD software. And the traditional CAD design flow doesn't support this at all, right? So the typical way that you would build something, as long as CAD's been around, is you build your sketch, you build your part, and then you build another part, and you put those together, and you build a part that goes on top of that. And so you're really building from the smallest down up, which makes it very hard to change and manage what's going to go on, when everything's put together. So there's limited tools to do this in the opposite direction, which would be top down, and why PTC made this advanced assembly extension the way that they did. We also see that there's a slow, tedious process to design assembly process planning documentation. This can be a really complex process, trying to communicate requirements and integrate data, from design partners or whoever it is that you're working with, to send on to the people who need it. So these are the challenges that are addressed by our solution, which is the Creo Advanced Assembly Extension, which provides the tools that speed assembly design and streamline the flow of information from design to manufacturing. So the capabilities enable companies to effectively manage the assembly process, and reach the optimal design in less time, with more flexibility. So there are some specialized capabilities that advanced assembly really, really works well with, and that is to manage the top-down design assembly process. That's the first one, as well as support to design and build-to-order initiatives. Managing assembly performance is another big key capability that advanced assembly supports, as well as the automation of and creation of assembly process planning documentation. So we're going to touch on each of those, and then we can see an example of how some of these key concepts work inside of advanced assembly. We're going to look at the top-down and concurrent design process, kind of the design workflow that you might use for that. So to talk about some of the capabilities, the first one, and the really big one here for this demonstration especially, is the top-down design. So this is supported in a couple of ways. The first thing is the skeleton model. So the skeleton model is a model that allows you to plan the assembly framework using this tool to define the assembly structure. So what are the key pieces of geometry that define my assembly, right? And what is this going to look like? Where are my boundaries? So this would be something that the team or the lead engineer or someone would come up with and create the skeleton model. You can see here for our train, it's perhaps these green lines that say this is the profile of the train, this is the width of the train, the arch of it, right? What's the cross section look like, as well as here's the floor. You can see here we have surfaces that are part of the skeleton model. Where are my walls, and what's my exterior surface gonna look like? So we're gonna see this in the demonstration, but I just wanted to point this out here that this is what the skeleton model does. And you can also define motion skeletons to support mechanism design and evaluation, as well as distribute that skeleton data to establish design criteria, support concurrent design, concurrent development, and enforce, best practices, so referencing. And we'll talk about how you distribute this skeleton data to do that, to support the concurrent design and enforce that design criteria best practices. We also have a reference viewer, and this gives you the ability to graphically visualize dependencies and relations to understand change propagation, because we need to be able to look at the model and understand how these pieces go together and how to best share or change our assemblies, right? So giving you a little bit of insight, a little graphical view of, hey, how is everything related to each other? And if I change this, what else is dependent on that, or what could I change that has all of these things, referencing it. You also have reference control. So you're able to define best practices to manage or limit the assembly component references. The fewer references that you have, the better, because it allows you to be more flexible, right? So that's where that skeleton model comes in, and you're able to enforce the reference component references. So what are you going to attach your parts to? We need to be really logical about what everything references so that we can keep our assemblies the most flexible over time and the most flexible for changes. So this allows you to lay out that logic and communicate it with the rest of the group or the design team to say, these are the references that I want you to use, and make it very easy for them to do that. So this kind of goes hand in hand with concurrent design. So this top-down design process inherently helps that concurrent design process. And this is through a couple of ways. The first thing is data sharing, so that we can all work together and you have the things that you need to get started. When you're ready to design your part, you don't have to wait for anybody, and you know that you're using the correct data, right? So you can define and publish contact interfaces between subassemblies and components. So these, however they're defined, you can copy them into other subassemblies, and we can talk about this in the demonstration as well. You're also able to communicate and share reference geometry with the extended design team, and then eliminate unwanted dependencies and references. We also have inheritance models. This allows you to define one-way associative propagation to derivative parts. And this allows you to support the concurrent development of downstream deliverables that reference these inheritance models, so that if you provide an inheritance model, downstream, they can make changes for whatever they have to do for the downstream processes. But if you make changes to the original model, that'll propagate to their model, but their changes won't propagate back to the original. So that one-way associative propagation allows two people to work on something at the same time and still be, working on the same most up-to-date model. Our assembly configuration, we have interchange groups. So tools such as interchange groups, if these parts always go in the same way, don't waste time choosing a million references. Just choose the surface to mount it on, and then you get on with the rest of your work. So this supports configure and build to order initiatives, because you can use functional interchange groups to replace groups with others. You can also just define design logic and rules to support the rapid creation of custom product variants. So whether that's defining reference tags to automate the assembly, define configuration rules, enable reference forwarding, all these tools allow you to quickly support that interchange group, as well as design to order. So change things up based on what the customer orders. Define simple programs to automate product line customization, leveraging input parameters. Also, you drive the creation of a configurable product from a spreadsheet, layout tables, or programs. Our assembly process planning tools. So we need documentation for assembly and how to know how all of this works together. And we want to use our CAD data to do that, right? So you can automate the creation of assembly process plans and manufacturing documentation with advanced assembly. So you can generate associative manufacturing bill of materials for each assembly step. You can publish assembly process plans for web delivery, a lot of different options that you have to support an automated and streamlined assembly process planning documentation creation process. The last thing we're going to talk about is visualization and performance management. The key here is only look at as much data as you need to. Don't overwhelm yourself or your system. And so there are a couple of different ways to do this inside advanced assembly. The first is to use skeletons to define functional subsystems and work effectively with large data sets. So by using the skeleton model, you can bring key reference geometry from other subsystems or boundaries between subsystems into the one that you're working on, right? The ones that need it. So that way, when you open those subsystems, you don't have to have other subassemblies open just to reference parts or surfaces that might be in there. You can actually bring that reference right into the one you're working in. So only have the data open that you need to work with, as well as using lightweight representations and shrink wrap. So external shrink wrap geometry reduces load time and increases system performance. The shrink wrap is a lightweight representation of your geometry, right? So you can bring in, if you need to see different pieces and information, different geometry, you can include that in a shrink wrap, which takes out a lot of that behind the scenes data. So this allows you to see large pieces of your assembly without overwhelming your system. And it also allows you to share this shrink wrap geometry without sharing your personal IP. So that's where that security comes in. You can shrink wrap your whole assembly. They can see every detail of the geometry that you want them to see. They can, reference it, but they can't actually see the information that's behind it. So that's an option for advanced assembly. So I'm going to move into the demonstration now, and we can take a look at an example, walk through a use case of how some of these tools are used together. So here we're looking at that train assembly that was shown in that PowerPoint, and we're going to take a look at the skeleton model and the top-down design process. So you'll see here we're looking at the skeleton model of the passenger train car. And you can have as many skeleton models as you need to. You can have one for every subassembly or whatever, but you're able to do it from the top down. So the skeleton model is special because the Creo knows that this is used for the assembly planning process, and it does not show up in your bill of materials. So it knows that these aren't parts that are going to manufacturing. It's just geometry to use as reference and logic control. And it always shows up as the first thing in your assembly. So you can see in the model tree that we have the passenger car assembly open, and the first thing there, no matter when you would create it, is that skeleton part. So we can start using some of this information to create the rest of our assembly, right? So if we've laid out, okay, this is, from a top-down design, this is what we want our assembly to look at. These are the boundaries we care about. This is probably what would need to be changed in the future, if we need to change the profile or the size or the shape, or where the windows are placed or the doors or the floor. These are the things that we care about, and these are what we want the rest of the subassembly parts to reference. Because if everything references these, then when we change them, everything can update automatically into a new position or a new, a new configuration. So the way that we do this is we take the skeleton model geometry, and we actually copy and share it into the subassemblies that need it. And so in this way, I mentioned earlier, we talked about representation, right? Don't overwhelm yourself. So if this is all from the top level, you won't have to have this top level assembly open in order to work, reference the geometry from it in the subassemblies, right? So we will also see how this looks in a minute. But here we're going to use our published geometry, which is how we group geometry that we want to copy. So this is just a way to group things. So if we're creating something, for the exterior, maybe that subassembly is going to reference, certain curves and surfaces. So these are the ones that are most relevant to them. This is what we want the structural subassembly to use to guide their references, to guide their design. And then we can make another group for the interior, right? So if you have a group working on the interior, they're probably going to need the boundaries, the wall to see where it goes, those doorways, the partitions. They're going to need the windows and the arches because, that's going to define the interior where they're going to meet up, right? So now that we have these grouped, we can see the groups show up in our model tree, and then we can copy and paste those into the appropriate subassemblies. So here we have our structural subassembly. We're just going to bring this skeleton geometry into it, and we can see that copy geometry shows up right there. Same thing for the interior. We're going to copy and paste the interior, the skeleton geometry that is relevant to the interior. And now, we can have someone working on the structural subassembly at the same time as someone else is working on the interior subassembly, which, if you were making this from the bottom up, it would be very difficult because the interior is going to be hard to make if you don't know where the ceilings and the walls and the floor are. But here we're able to work on many at a time. So here, this is the structural subassembly, and we can see that we have that geometry from the skeleton model to make our arches. So we can actually use that to reference. We can use it to create our part. And now, if for some reason at the top level we decide we need to change the shape of these or change the widths of them or make them thicker, it will update all of these that are in the structural subassembly, as well as change anything else that references this. So if you have to make the arch thicker, right, and it brings the ceiling down, it would change the interior, it would change the structural. So I hope we're getting the idea of how powerful the skeleton model is. And then once you have that skeleton geometry, this is just regular Creo work, right? Chop the top off, whatever else you need to do. But you have the option to pattern that. So everything, again, is still referencing that the reference that was the geometry that was decided upon at the top level. So we can change the spacing, no big deal. It's just regular Creo work. And then when we move back into the other subassembly, we'll see that, we could be working on, someone could be doing that we just saw at the same time as someone else is working on the interior. So we're just going to open up that master representation. So this is everything inside of the interior subassembly. And we see that we have a wall already created. And we can start working. So if we're going to create this window, or we need to create that, how this window is going to interact between the interior and the structural, right? So we copy that loop. And we're going to use our sheet metal tools to create a window. So if you pull this out, and then like I said, this is just your typical work. It's just that you're starting with a sketch that was agreed upon at the top level that is referenced by everybody and can be changed very easily. So this outer wall is going to be the end of the window, right? So that's the end of if it's going to meet up with the exterior wall, the interior and the exterior wall, that's where it should be cut off. And so now that's referenced as well. Again, we can pattern that, make all of those the same so that if one is changed, others are changed as well. Keep the model flexible. With an assembly this large with so many passenger trains, if this isn't a flexible model, it would be impossible to make a change late in the design process. It would just take way too much time. And then we can change the representation. Here from the model tree from the top level assembly, you can look at whatever representation you'd like. So whether that's certain shrink wraps, whether that's certain lightweight representations, or the full representation of certain subassemblies or other subassemblies. Only look at the information that you need at the time, because again, you don't want to overwhelm yourself or your system. So here, an example of that is the shrink wrap. So we're going to update the shrink wrap that's in this passenger door assembly. And that's because we need to see, for the passenger door assembly, perhaps we need to see geometry from a different assembly, but it's not part of the skeleton structure. So we don't want to copy the geometry, right? It's not what we want to reference. But we do need to see it in this assembly. But it would be way too overwhelming to have all of that second subassembly open at the same time. It's just too much information. It makes our model cumbersome to work with. So an option would be to shrink wrap the geometry that's needed to be visualized, and then copy that into the subassembly, so that now we have a lightweight representation of those structural elements that we need to be aware of or reference, but we don't actually have all the information behind it, because it could be a very overwhelming, depending on how detailed your CAD information is, pretty overwhelming. So here's one thing that's very important. So we've been talking about how this skeleton model is used to automatically update anything that references it. But you should know that that's because we can have it set to automatic update. But if we're working on a critical piece of information, a critical element of our model, and we want to make sure that, hey, you know, I know that this references the outer wall and this structural beam, but if either of those are changed, if the location is changed or the size, I don't want it to automatically update this critical element because it might not be right. I want to double check it. You can set it to manual update with notification, manual update, whatever it is that you want to do, so that those won't be automatically updated in the case of a top level design change. So I can't, you know, the door might not be a super critical piece of information, but we need to make sure that it opens, right? So it's not just a structural assembly at this point. It doesn't just sit there. It's not the shape of the wall. We want to make sure that the door is still going to be functional. So we're going to use that skeleton model to create that piece of that element. And then we can visualize the rest of this information that we have, start getting a better idea of what it is that we've created so far. You can see there's the skeleton model of the passenger car. We were familiar with the geometry at this point, the curves and surfaces that we've used to put into all the rest of our sub-assemblies so that we can control the references and do that concurrent design process. No one's stepping on each other's toes. Everyone has the information they need from the very start. No one waits for anyone else. All the parts fit together at the end because we have those boundaries defined. So now that we have this whole train, you know, built out, we're going to look at what a change, top-level design change would look like. And so to do this, we're actually going to open a design exploration session. So a design exploration session, for anyone who is unfamiliar, is a tool that comes with our design exploration extension. This is a tool for managing different versions of your model. So it gives you a sandbox environment to play around with your model, make modifications, where you never run the risk of breaking or overriding that master copy that you came in with. And this is done by the checkpoint tree. So we see that we have that pre-modified checkpoint.
Emily, yep. I'm going to interrupt you real quick for a second to make another point. So this design exploration extension that Emily is about to demonstrate in conjunction with the Advanced Assembly Extension, this is a standard extension in Creo 6. So if you're on Creo 6, you have this capability. Like she said, it's a checkpoint because a lot of companies, what they do is if they don't know, if they want to make different variations of a file, they'll have 5, 10, 20 different files of the same product just because they're trying to experiment and figure out what's going to be the best and what looks good. And to Emily's point, what Design Exploration Extension does is it allows you to create these different checkpoints within the same Creo file so that everything's in there. You don't have to search another file for all those different designs that you may have that are related to one specific product. So just wanted to interject that. Thanks, Emily.
No, that's a great point. Breaks up my talking to make sure that, this is something everybody hears because it is a really great tool. And if everybody has it, something that you should definitely look into. And the way it works is it's this checkpoint. So as you make modifications, you can save checkpoints along the way when you get the design to a state that you like. And then you can go back to previous checkpoints to activate previous checkpoints, and you can see, okay, well, before I made that modification, it looked like this. What if I go in a different direction? And that's really the key here. But we're going to make this top-down design change. It's a big change, right, to this whole large assembly. We want to make sure that we have that pre-modified version saved, and it's safe. There's no risk of overriding that save as file or accidentally saving instead of save as. And then if we don't like the design change, we can go in a different direction. So we're going to actually make a change to the skeleton model. We decided for some reason that we need to change the profile, or we want to just see what it looks like to change the profile because it's so flexible that we're able to do that. We're able to see different versions of our large assembly pretty easily. And you can see here that it's regenerating a lot of different features because all of those features reference that skeleton geometry or reference something that references skeleton geometry, except for this notification. So here we have highlighted in our model tree a feature that was not updated, and we got that notification to tell us, hey, this is something you need to look at. And that's because we have that manual update with notification set. I did forget to mention earlier, there's no dependency option, so you can set something to not be related to the skeleton model if you'd like to still use that geometry. But here we can look at the changed and the outdated. So the outdated is the one that we set before, and the changed is the new one that if it follows that update to the skeleton profile, this is the new feature, the new shape of the feature. And so it was very easy to see, okay, well, this is going to work for my critical pieces. This isn't going to work for my critical pieces. And we're able to be flexible with the shape of our assembly. So this was all I had to show for a demonstration today. Again, really supporting that communicating the design intent and best practices very clearly and easily able to be communicated with anyone in the design team, as well as the assembly plan and logic. There is no interference at integration. When you put all these pieces together in a large assembly, there's no interference. You can manage the references for easy changes, make sure everyone has the references that you'd want to be able to change in the future for a flexible model. Changes propagate automatically, saving a lot of time. And everyone's accessing up-to-date information. So, just to reiterate, this allows you to design concurrently because you have the needed information. It loads quickly, right? You're not overwhelming your system because any references you need can be copied into your subassembly. You only have to have open the pieces that you actually are working on. And then you have those lightweight representations to be able to see things that you might need but are too heavy. So it gives you a lot of options not to overwhelm yourself or your system.
So Emily, I think you answered one of the questions that just came in. The question was, why is Creo not prone to crashing with and meaning in the relation to these large assemblies? And I think you answered it in the way that this loads is it's loading just the areas that you're working on with this large design. It doesn't open up the whole design.
Yep.
You
can pick and choose.
Is there anything else that contributes to that?
It has to do with the math kind of running behind the scenes. Creo is a very robust model, so it can handle large assemblies. But yeah, a big key to it is that you have the ability to only have open what you need to have open. You don't have to necessarily have Group A and Group B open. If you only need a little bit of something from Group B to work on Group A, you can just pick and choose what you need to do.
The other thing that I think people need to be aware of is that Creo files are normally 1/3 of the size of other CAD files, whether it's SolidWorks or Autodesk or Siemens or especially CATIA. They're at least 1/3 the size, and a lot of the reason is because of the flexible modeling capabilities within Creo. So back in 2011, when PTC changed the name from Pro Engineer to Creo, they basically took the Granite kernel that Pro Engineer runs on, and they added the code for this software called Co-Create, which is direct modeling. So they wrote that direct modeling code from Co-Create onto the Granite kernel, and that's where Creo came in. So what that allows you to do, is a lot of people know, but some people may not, it allows you to create late stage design changes very quickly. So instead of a change taking a few minutes, it takes literally like maybe 10 seconds. It's just a handful of clicks. So that direct modeling capability has led to other abilities within Creo as far as being able to do better surfacing and also in enhancing the Advanced Assembly Extension. So with that, Emily, I'll let you continue.
Absolutely, thanks. That was a great point. So some of the big value points, so these are a lot of tools that you get with Advanced Assembly. But the question is, how is this useful or valuable? And the customers that have implemented this in their design process started using these tools for top-down design. What they say is the most impactful for them with these tools is that it reduces time to market and cost, because it allows you to streamline product development activities by enabling that concurrent design and development. So things are moving much quicker. You're also able to drive predictable changes from the skeleton model. You know exactly what changes you're able to make, and it's easy to make those, which eliminates a lot of integration errors and rework. As far as costs are concerned, again, you're speeding that assembly design and development by enabling concurrent design. They're able to communicate and collaborate effectively, which reduces follow-on meetings and design reviews, because things just work, the first time. So it eliminates a lot of that, as well as lowering the life cycle cost, which allows you to speed the creation of downstream deliverables and manufacturing documentation, and eliminate systems integration errors to reduce manufacturing errors and scrap. Another point here is that it increases your product quality and innovation, so you can create and evaluate more concepts and ideas within the allotted time. So it really allows you the flexibility and the creativity and the tools to explore all of the different designs that you might be able to come up with, which always leads to a more innovative and a higher quality product. You also are able to improve assembly design using the tools to facilitate planning, collaboration, and concurrent development, because you now have the tools to support the logic from the top down. So everything is very well thought out and can be implemented accordingly. And this last point here is that it allows you to develop and define new markets. And this has to do with the support to design and build to order initiatives that meet customer-driven requirements. So it gives you, not only more flexibility with how you model, but more flexibility with how these assemblies are assembled for customer requirements to do, more custom design and build to order initiatives. So in that way, you're able to provide more flexible products as well, more options to have out on the market. So these are hopefully the takeaways that you can see in your process. If this looks like a tool that could be applicable to your design process, and I can pass it back over. This is all I had to show today.
Yeah, the other value that Creo Advanced Assembly adds that you don't have listed here, that it helps reduce the lost amount of time from employee accidents, because your engineers and designers won't punch a wall and break their fist when they get frustrated. Or damage the computer. So we could add loss of hardware in there too.
Right.
So anyway, hey, great job, Emily. Excellent.
Thank you.
I'm going to take the control back just for about 2 seconds, because I know we're over time, and we answered our questions as we were going along, which is great. So I want to thank our audience. I want to thank everybody for being on, and also thank you, Emily. I think you did a fantastic job. I'm going to be sending everybody a link. We'll have this uploaded to our YouTube page later today. So I'll send the link to everybody so you can watch this at your leisure. But if you have any questions or need any additional information, here's how to contact us. You can email me, or you can send an email to us at info@3hti.com. I don't mind if you call me. If you like the webinar, great. If there's anything that we can improve on, I'm always open to any suggestions, because we want to, we want these to be useful and informative for our audience. So once again, thanks everybody for being on. Have a great Friday and an awesome weekend. And we'll end the webinar now. Take care.